So let's just talk about the cycle detection in a directed graph. So here we have this directed graph, and you can see all the edges has the direction. Now here to detect the cycle, we're gonna use the DFS or the depth first search. So as we know, to perform the DFS, we use the stack data structure. So here we're gonna use one stack data structure, and also we need to track the vertices that we have visited, and also we need to maintain one parent map. It consists of the vertex that we visit and the parent of that particular vertex. So here we're gonna use different flags. So here the flag -1 means the particular vertex is unvisited, and the flag 0 means we have visited that particular vertex and the vertex is in our stack. And also we have the flag 1. So flag 1 means we have visited that particular vertex and the particular vertex is currently out of our stack. So these are the flags that we're gonna use. So let's now start the traversal of this graph. So we're gonna start the traversal from this vertex A. So initially, because all the vertices are unvisited, so all of their flag will be set to -1. So because we have visited A, so A will be marked as visited. We're gonna push that on the top of our stack. Now in the parent map, we have visited the vertex A, and it does not have any parent because that is the starting point. So now the flag will be modified to 0 because we have visited the vertex and that is in our stack. So from here we can either visit B or we can visit D. So let's now visit the vertex D. So that means we're gonna mark this as visited. We're gonna push that on the top of our stack. And also in our parent map, we have visited the vertex D and the parent is A because we have came from A to D. And here we have to modify the flag. So here the flag will be set to 0. Now from D, there are no unvisited nodes, so we cannot go anywhere. That means now we have to perform the backtrack. So we have to go back to the parent node A. So that means we're gonna pop D from the top of the stack. So that means the flag will be modified. So currently we are at the vertex A. From here we're gonna visit this vertex B. So that means we're gonna mark this as visited. We're gonna push this on the top of our stack, and in the parent map we have the vertex B and the parent is A because we have came from A to B. And also we have to modify this flag. So now the flag will be 0 because we have visited this node and that is in our stack. Next we're gonna visit this unvisited node C. So that means we're gonna mark this as visited and we're gonna push that on the top of our stack. And also in our parent map we have the vertex C and the parent is B. And here we have to modify the flag. So the new flag will be 0 because we have visited this node and also this node is in our stack. Now from this node C, we can take this edge and we can visit A. But because A has the flag 0, so because here we are visiting this node which has the flag 0. So that means this node is already visited and that is already in our stack. So that means we have found one cycle in our graph. Now here we can use this parent map to determine the vertices involved in this cycle. So currently we have this edge from C to A. Now the C has the parent B. So we are going from B to C. Now B has the parent A. So from A to B. So if we start from A, so we're gonna visit B, then we're gonna visit C, and then we're back to A. So here we have the cycle in our graph. So let's now suppose we do not have any cycle in our graph. So let's now see how things play out then. So currently we are at the node C Now from here we cannot go anywhere because there are no unvisited nodes. So that means we have to backtrack. So that means we have to pop C from the top of the stack. So here the flag will be changed because we have visited this node and that is out of the stack now. So we are back to the vertices B. Now from here also we have nowhere to go, there are no unvisited nodes. So that means here also we have to backtrack to the node A. So that means we have to pop B from the top of the stack. Here the flag will be changed to 1. So we are back at the vertices A. Now from here also we do not have any unvisited nodes. We have to pop A from the top of the stack. And here also the flag will be changed to 1. Now because our stack is empty, so that means we have done traversal of our graph using the DFS and we do not found any cycle. So that is in case when we do not have any cycle. So this way we can use the DFS to determine whether we have a cycle in our directed graph or not. So hope you understand the concept. See you in the next one. Take care.